Hello everyone. Today I will discuss Chapter 2 of the EasyBuilder Pro user manual. In our last video, we covered the installation of EasyBuilder Pro and the applications that come with it. Within this video, we will cover our Utility Manager's functions and features. Check out the description below for quick links to different topics discussed within this video, as well as a link to our website. And don't forget to subscribe to receive updates on the latest videos within this series. Let's start by running a quick search for our Utility Manager. Now, as the name implies, the Utility Manager was designed to help us find the correct utility for our application. With the Utility Manager open, we'll get an overview of our features and navigation. Starting with our HMI model in the top left corner, if you've just opened this for the first time, yours might say IP series. Selecting this will reveal our list of HMI models. For right now, I'm going to select our CMT series. We have a couple of tabs on the side, and one thing I want you to notice, and I'm going to flip to the maintenance section for this, is that the programs available to you really depend on what HMI model you select. So in the Maintenance tab under CMT series, you'll notice we have our CMT programs available. And if we switch the HMI model to, say, the IE series, for example, you'll notice these programs change. This addresses a very common question I receive in which someone will go to the right tab but have the wrong HMI selected and won't see the correct programs. In other words, it's important to select the correct HMI model for your application. Okay, so we've addressed one very important aspect associated with the Utility Manager. Let's take a look at our shortcut feature. Now, we can create shortcuts for easy access to various applications we use within our Utility Manager by simply clicking on the heart located on the application. This then gives us a link at the bottom for quick access. I will note that you still have to have the correct HMI model selected in order to use that link. For example, if we add a shortcut to EasyPrinter, we can use that program with any model except our CMT series selected. This is because our CMT series can't use our EasyPrinter application. So if you're doing work with a CMT model and you decide to open EasyPrinter because you have an IE sitting next to you, you will still have to switch to the correct HMI model for the shortcut to appear. Also, on the bottom left, you can select Edit to remove existing shortcuts you add if you no longer use them. On the bottom right, you'll notice some diagonal lines. Here you can expand the menu size, and in the top right corner, we can minimize or close the application. With this out of the way, let's look at some of the programs not covered in our last video. Starting with our CMT series and within our Design tab, you'll notice that within this tab we have three programs: EasyBuilder Pro, Easy Address Viewer, and Simulation. In our last video, we covered very briefly what EasyBuilder Pro is. It's really the centerpiece of this whole ecosystem of applications, and because it's the main topic of our next video, I won't be covering this application today. However, we will take a look at our Easy Address Viewer. From the drop-down menu on top, you can select the driver that will be used within our project. I'll go ahead and pick one of our Rockwell device drivers as an example. As you can see, this application is a useful tool that will allow us to review the register schema for your selected PLC driver. There's not too much else to show here, so I'm going to go ahead and move on to our next application. The simulation will allow you to run an online or offline simulation directly from a compiled project file of your choosing. I've actually already demonstrated this in our last video, but because it's a useful tool, I'll go ahead and show you guys one more time. Once you open this application, you'll be prompted to select a file. From here, you can select an EXOB or CXOB file, depending on what HMI series you have selected. Once you've found your project file, you can then run an online or offline simulation. And it's as easy as that. Now we'll move on to our Analysis and Testing tab. The next application we're going to take a look at is at the top. Here we have our CMT Diagnoser. The CMT Diagnoser is an advanced diagnostic tool built only for the CMT series. This diagnostic tool is fantastic, and if you're comparing it to EasyDiagnoser, the difference is night and day. To demonstrate this, I'm going to use CMT Viewer and CMT Diagnoser on a project I've already pre-configured. Using CMT Diagnoser, I can monitor and control most of my project without the need to be directly in front of the HMI. With CMT Viewer open, I can see my project has received the device no response message. So let's use our Diagnoser to figure out what's wrong. Before I begin, it's important to note that the CMT Diagnoser must be enabled within your project by heading to the System Parameters and selecting the Remote tab. Then, under Diagnoser, select Enable, and for this instance, I used Password Free. With the Diagnoser open and the Object tab selected, I can view any window within my project. And within each window, I can view the value assigned to each object and modify this value if necessary. One advantage that unfortunately I can't demonstrate today is the ability to monitor tag-based PLCs, which is one of the limitations of EasyDiagnoser. I can see here that I have 7 local tags that are currently active and displaying a static value. My PLC tags, on the other hand, are not visible through VNC Viewer and are displaying a polling status, indicating that no data has been received from this device as of yet. As a practical demonstration, I'm going to demonstrate how to find and add the appropriate watch address to read a device error code. We'll start by heading to our project's system parameters and looking within our device list. We can see that our PLC is specified as local device 4. This number will be important when selecting an appropriate watch address. Because I don't know the specific system tag to monitor our connection with local device 4, I'm going to select the Project tab and open our address directory. Here, I'll search for the correct local device 4 monitor address by typing device. Within our search bar, we can narrow down what tags will help us diagnose our connection issue. There's a couple of tags that could point us in the right direction. We could open our Communication Status tab for Ethernet devices and select a bool tag and use this to attempt to reconnect to our device. Or, more appropriately, we could open our Communication Error Code tab and select Error Code for Device 4. This is revealed to be Register LW9403, which we can add into our project. After adding this watch address, you'll notice our error code is 9. Now we can use the EasyBuilder Pro user manual to find what's causing the device no response message. Running a quick search for our LW9403 address should bring us a list of error codes. Within this list, we can see that error code 9 is associated with an incorrect IP address or an undetermined issue that is making it impossible for our device to connect. If this wasn't the case and we found our device error code to be normal, we could then move on to our Packet tab. Within this tab, we can run a capture to retrieve packet data within what we call the activity area, which is the current selected window. In our Activity tab, you'll notice we can specify the packet type, device address, and station number, and even a keyword. For now, I'm going to leave these settings alone and select the orange button to run a capture. Clicking it again after several seconds will pause our capture, allowing us to scroll down the list. After scrolling, we can see that we have several instances of tag-specific errors. By looking at this information, we can easily see, in this case, that the HMI failed to read the corresponding tag in the Result tab. We can take the package ID number and its corresponding address from our Activity area or from our Polling tab, and then use this in our Object tab to find the object's location. As an example, I'll track down our NXBool object. Heading over to the Object tab, I can easily see our NXBool within our address column. Double-clicking this object will highlight its location in CMT Viewer, which I can then find in our EasyBuilder Pro project. Before I move on to our Macro tab, I'd like to quickly point out the Device tab. Within this tab, we can see device information, including the IP of our device, if we're using an Ethernet connection. This is important because we can add a watch address, just as we did to read our device error code, that will allow us to make an online change to the PLC's IP within our project. With that said, I'll move on to the Macro tab, where we'll discuss some of the new features found within CMT Diagnoser in EasyBuilder Pro version 6.04. In the latest version of EasyBuilder Pro, we can now perform macro debugging in real time. Within our Macro tab, you can see that I can select between an Execute and Debugging menu. To start debugging my macro, I'm going to select my Debugging tab, find the macro I want to debug in my drop-down list, and select it. The macro will then be displayed in our debug dialog. While on the bottom right, you can see our execution status or output display. And on the bottom left, you'll notice we can add a watch address. To start off, we're going to add some breakpoints in our macro. A breakpoint is used as an intermission in between different areas of the text. And as the macro continues debugging, it will stop at these breakpoints. At the top, we have a few ways to control the process. The first being our Start Debugging button. Next to this, we can stop or pause the debugging process. And on the far right, we have two specialized buttons that allow us to isolate and debug our macro line by line. For now, we'll click and add a breakpoint just under Macro Command Main. One next to Delay in our result, and one at Next. I'll head over to the Execute tab and begin macro execution. After execution, I should see a small red dot next to Debug on the top of our Diagnoser. Heading over to our Debugging tab, I can see macro debugging has begun. Now I can access our watch list and add some variables I've created within our text. Running through the debugging process, I can now watch the changes to our variables in real time. This is an extremely useful way to monitor your macro and make sure it's performing as designed. Now that we've covered the macro section, we'll move on to our MQTT Diagnoser. Our MQTT tab will display the type and state of our MQTT server, as well as our connection log. Moving over to the Address tab, we can see the topics we've published, or in this case subscribed to, and by checking the corresponding boxes, update the data in the corresponding address. And since in this project we're the MQTT subscriber, we'll move to our Subscriber tab, which will allow us to view the data length and timestamp associated with the MQTT topics that we've subscribed to. Now that we've covered our CMT Diagnoser, we'll move on to the next application within our Utility Manager. Just underneath our Diagnoser, you'll find EasyWatch, which is a very useful tool that I've already covered in our last video. And below this is our Reboot application. It's extremely easy to use and very useful. The only necessity is that you must be on the same IP subnet as your HMI to perform a reboot. Within our application, I can either enter the HMI's IP or perform a search for the HMI on my local network. In this case, I'll enter my HMI's IP, and when finished, select Reboot. Assuming the process goes uninterrupted, I will receive a notification upon its success within the application's dialog menu. Now I'm going to open our serial pass-through application. During the initial setup of this application, you will be required to download the virtual COM driver. And after this, we can move forward with our configuration. At the top, we'll select our PC to HMI interface. Right now I'm connected via Ethernet. Now I would define the communication parameters for my HMI. After this is finished, I would click Apply. After this, I would open my PLC software and set the communication COM port to the virtual COM port established in our pass-through application. After which the HMI should automatically enter pass-through mode, and it's as simple as that. The last utility in this list is our local Ethernet pass-through application, which can be used to perform an Ethernet pass-through to the PLC within your project. I'll go ahead and demonstrate this feature using a very basic project that I've created on a CMT 3090 that is equipped with a Weintek PLC. A local Ethernet pass-through to the PLC can be performed very quickly, assuming that you have the correct network configuration. I'm currently connected to my HMI through an Ethernet hub shown in the following diagram. Within my pass-through application, I'll configure the IP address of my HMI and the IP of the PLC, and then click Connect. You'll see in the following dialog, we're now successfully connected. And that's all that's required to perform a local Ethernet pass-through to your PLC. It's important to note that a local Ethernet pass-through is only available for CMT HMIs. Moving on to our Publish tab, I'll discuss our upload and download applications. With our download application open, you'll see I can perform several functions when I download a project to my HMI. Our project checkbox will allow you to select an HMI project to download to your device. The project file will be in a CXOB format for CMT HMIs. If you don't have a CXOB file, you may need to compile your project by opening your project within EasyBuilder Pro, selecting the Project tab, and then clicking Compile. Just underneath this is the Runtime checkbox. This box is used to update the HMI's kernel. It's optional, but not necessary, unless it's the first time you're downloading a project file to your HMI. Below this, we can add our RW and RWA retentive memory files. These registers are used to store information on your HMI in the event of a power failure or power down, and are saved within the HMI system memory. And just below this is the recipe database selection, which will allow you to update a recipe database if you've created one within EasyBuilder Pro by selecting the corresponding DB file. If you'd like to add a custom startup screen, you can download a BMP file of your choice to your HMI by selecting the Startup Screen checkbox. A system settings file is used along with our Easy System Settings application to update your HMI's settings during project download. You can add them here by selecting the appropriate config file. Below these options are a set of functions used to reset or delete data or settings currently stored within the HMI. And below this is the option to download a Codesys application to our Codesys activated HMI. To perform a download, you can search for your HMI within the HMI name tab, or enter your HMI's IP address. If you prefer to use a USB cable, you will need to ensure that your HMI supports that function. Currently, the only CMT that supports this feature is the CMT3151. Next to this is our upload application, which should now be very familiar as it corresponds directly with our download application. To upload an HMI project, you will need to search for or enter your HMI's IP. With that properly configured, you can then upload an HMI's project or your HMI's historical data to your PC. The next tab is our Maintenance tab, where you'll find our Administrator Tools and CMT Viewer application, as well as a few others. Since we've covered both applications on top within our Chapter 1 video, we'll go ahead and take a look at the 3 applications below. The CMT IV application is used to update your IV5 or IV6 firmware, or to perform an OS upgrade using the appropriate bin file. The CMT server application is used to upgrade your SVR's OS or the web package via the appropriate bin file. And the Codesys firmware upgrade application, as its name implies, will allow you to upgrade the Codesys firmware of your Codesys activated device. All 3 of these applications are necessary, but as far as day-to-day usage goes, they probably won't receive much action. With that said, we'll move on to our final tab, Data Conversion. If you've watched our last video, you'll most likely recognize some of these applications. Today, I will be covering the Recipe Database Editor. Using this application, we can access and edit our recipe DB files saved within the HMI system memory. To do this, I'll open the application, select Import, and import our HMI's recipe DB file. Now that our database entries are visible, I can add a new entry or delete an existing one by selecting it. You'll also notice we have a Clean All button located at the top of the page that can be used to wipe out all the data within your DB file. Once you've reconfigured the data to your liking, you can save this to a new DB file that you can upload to your HMI. And that covers the list of applications available on our CMT series. Now, there are, however, other applications available on our non-CMT models that were not yet covered. These applications can be found within the Publish and Maintenance tab of any non-CMT model. As an example, within the Publish tab of our IE series, you'll find the Build Download Data application. This application is used to build a project file that you can upload to your HMI via USB or SD card. The project file can contain your recipe data and a user-defined start screen. After you've defined your associating files, selecting the Build button, this will produce a folder containing your HMI project that you can then upload via external memory. I'd like to note that this feature is also available on your CMT HMI by selecting the Build Download Files button within the Project tab of your CMT project within EasyBuilder Pro. The last application we're going to take a look at is the Data/Event Log information, found within the Maintenance tab. This application is used to check the number of historical log files found within the HMI. Opening this application, we can define the IP address of our HMI or search for the HMI as we've done before. You'll also notice we have the option to sync the HMI's clock with our PC. After the connection is properly specified, we'll select the Open button and the application will load, allowing us to view our historical log files. Because this application isn't widely used, and because we have advanced alternatives that not only allow you to view the number of log files but also to back them up, such as through our FTP function, I will not be demonstrating this today. If you found this tutorial helpful and would like to see more, head on over to our YouTube channel and select the Playlist tab. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.